Hello, everyone. My guest today is a distinguished award-winning planetary scientist, radio show host, and postdoctoral fellow at NASA. She is one of the recipients of the 10 Outstanding Young Americans Award in 2018, a prestigious award given to 10 Americans aged between 8 and 40 that exemplify, quote, the best attributes of the nation's young people. Please welcome Dr. Caitlin Ahrens. First off, Dr. Ahrens, thank you so much for taking the time to meet with me today. It's always a pleasure speaking with you. How have you been?
I have been great and busy. There's so much going on at NASA nowadays that it is absolutely exciting. And yep, we're doing great.
That's great to hear, for sure. So I've known you well enough for the past couple of years, and I'm acutely aware that you explode with passion whenever you talk about space science, planetary sciences, or astronomy. And in my opinion, passion is really the driver of action. We're actually seeing a lot of action in the space arena today, whether it be the rise of multi-billion-dollar companies, like SpaceX or NASA-funded exploration programs like Artemis. In fact, I have a picture of Artemis over here, the Artemis program. Unfortunately, the words are inverted. But I know that you worked a little bit on Artemis. So can you please explain the program?
Yes, so Artemis is going to be so fascinating, especially with our generation. It's been almost 49 years since we've last had a crewed mission to the moon. And so think about that, though. 49 years, how much our technology has developed since then, and then our drive to want to go back to crewed missions like this. And so Artemis 1 is supposed to be launching this year, November 2021. It's going to essentially be a dress rehearsal test flight for then Artemis 2 and then Artemis 3. Artemis 2 is then going to be the crewed mission, whereas Artemis 1 is uncrewed. But Artemis 2 is supposed to be scheduled at least for 2023 or 2024. It kind of depends upon the state of the world at the time. But we're very excited. We're all in a mass right now of what kind of instruments would we want to have, different kinds of payloads, what's the timeline that's going to happen, and how are we going to get there. So this whole dress rehearsal is fantastic for the rocket side of Artemis, but now we're getting into what kind of instruments, what kind of experiments do we want to bring back to the moon? Would we want to do something that the Apollo era did, or do we want to try to do more experiments? So it's very exciting for Artemis.
Sure, of course. And ever since the Apollo missions, we've really drastically increased the rate at which we develop new technology. And so, of course, the innovations that we've created over the last couple of decades will probably put us in a position to go back to the moon. Am I correct in thinking that?
Absolutely, absolutely. But it's all in the planning, though. So at least we have the motivation and the drive to want to go back to the moon.
Of course. Yeah, and I think the knowledge that one day future generations might be able to look up at the moon and say, whoa, there's an entire civilization up there staring back down at us. It's something exciting, to say the least. And every time I think about it, it sends goosebumps down my spine. Is that the most exciting part of the program for you?
Truthfully, the exciting part is that like we get to go back, and again, it's all in the generational mindset of it. My generation would not have had anything to do with the Apollo era, and so having our own version with the Artemis era now, and what kind of experiments are they going to do on the moon? I'm such a lab rat at heart. I love experiments, and so I figuring out like what are they going to do to at the moon, and what kind of moon rocks would they bring back, and it kind of just opens up this whole exploration for us.
Yeah, and in fact, I was at the Fondren Library the other day at Rice University, and Rice University has a fairly good collaboration with NASA ever since the Apollo missions. And Houston, we have a problem. Of course, the phrase originated from there, and so they actually have a sample of moon rock, and I went to go look at it, and it was just mind blowing. It was so fascinating to think that some object, some celestial object that we see in the night sky every night was there in physical form, housed in a library. It was just incredible. And I think that just brings back these emotions, these strong emotions to go back to the moon. And I think the Artemis program is really the driver of that.
Absolutely, absolutely.
Yeah. So, before I guess we dive into some of the more technical questions I'd like to ask you today, I really want to know how it is that you first got interested in astronomy, astrophysics, and of course, planetary science. How do you think your childhood shaped you to be the starry-eyed scientist you are today?
So I was definitely the weird kid at school where I would constantly like pick up cool rocks at the playground and take them home, and that was like my own like little rock collection. And I just understanding the Earth was really a starting passion of mine. And I believe when I was 9 years old, I got my first telescope. I actually joined a local astronomy club just for fun. It was an after school uh, hobby, in a sense. And so from that program, I just at first took it as like a hobby. I really enjoyed optical astronomy at the time. But from that astronomy club, I was part of the Central Appalachian Astronomy Club based in West Virginia. And from that club, I got to meet astronomy professors from everywhere, and I got to meet astronauts in that astronomy club as well. And that's where it shaped me into going like I could actually do this as a career. I didn't know that.
Right.
I and so growing up with these people and all through my high school age and getting to network and meet even more people, it just kind of snowballed into this passion of awesome, I want to do astronomy, but then there's all sorts of kinds of astronomy out there. So where to even start?
Yeah, it's such
And
a
so, uh,
dynamic field. There's so many subfields inside of astronomy. It's really this collaboration between the sciences and the arts. And that's what really makes astronomy so special and so unique compared to all the other sciences. It has physics, obviously, it has chemistry, it has mathematics, it has geology, it has all sorts of different scientific fields. And you even need astrophotography. You need all sorts of different industry professionals to really make astronomy what it is now. So it's really impressive.
yeah, absolutely. And so I was truly overwhelmed my freshman year of West Virginia University for my bachelor's degrees because it was a matter of where do you even begin? And so I started out in radio astronomy there for a while. I was doing some seismology work in the geology department. And just so happens I landed an internship down at Flagstaff, Arizona. And from there, I got to work with the Mars Global Surveyor data. And by that point, Mars Global Surveyor, what had been a dead mission for quite a few years then, but getting to see the data and what all kind of mysteries I from just that one data set, and oh my goodness, it's Mars. And so I again did not have a clue that planetary science was even a thing, let alone a
Right,
career.
right.
And so it was like I gotta know more. And so it really went down into a rabbit hole of what else can I do? What else can I get my hands on? Who do I need to meet? Where do I need to go? And that's pretty much what happened was just a instantaneous moments in time to just kind of oh, okay, let's do this. Let's do this. Let's go there. Let's meet this person. Let's see what happens next.
Mhm. Yeah, and it's very rare that people's passions eventually turn into their careers, and that's, I guess, precisely what happened to you. So
Absolutely. Yeah.
that's of course. Yeah, and I know there's so many other, when you actually came to our school to give a talk to our students regarding space science and astronomy, a lot of our students were so motivated after that. They really wanted to go after NASA internships. They wanted to work at NASA. They wanted to be astronomers and scientists. And you did a phenomenal job really communicating astronomy and science to our students there. So we're grateful for that.
Thank you so much for saying that. Thank you.
So there's so many students that didn't know that they had a passion in astronomy and physics, and after that talk, it enlightened them to follow that career path, and you sort of served as the kindling for their passion in astronomy. So that's really phenomenal. Um, you know, now I guess moving on to the next question. There's a lot of talk in the media amongst scientists, engineers, and even some economists about a serious future of humanity in space. We're even seeing like private-public partnerships in space exploration through the rise of aerospace companies such as SpaceX, Blue Origin, and Virgin Galactic. Now, what do you think about all of this? Do you think we're all destined to be amongst the stars?
Oh boy, it's a eventually. I'll call it an eventuality. Whether it's purely for exploration, I hope that's the route that it goes. I'm not one specifically for space tourism. We're not even there yet at all. But for if you were to look at through the lens of like an explorer, and let's see how we can put habitats on the moon and habitats on Mars. It's not going to be a permanent settlement or anything. It's truly just going to be hopefully just for the sake of discovery.
Sure.
What can we do to set up temporary laboratories at the moon and Mars? That would be fantastic. And if it comes down to having private space companies to help with that, with the materials or providing the rocket fuel or just hitching a ride on their rocket for us to be able to do that, so be it. That would be fine. That's a perfect collaboration. And that's wonderful that space companies, that private space companies are truly coming about. And it's so fascinating. And it's not just the US. There's international private companies coming about. It's wonderful to get that kind of drive. But I feel like if we were to steer toward commercialism and tourism and that route, we're gonna miss the whole opportunity of, oh my goodness, we're in space. Let's discover some stuff together, and instead make it into just this show pony kind of deal where it's all flash and no science. So I'm really hoping it's geared more toward discovery and exploration.
Yeah, for sure. I think it'll take a while for us to reach a future where humanity will be in permanent outposts on other planets for sure, maybe even a couple of centuries. Do you think that's probably how long it might take?
Oh, probably. Yeah, it's definitely not going to be next Tuesday or anything.
Yeah.
It's certainly probably not going to be even 30, 40 years down the road. There's still a lot that we need to even learn about the moon and certainly Mars. We're not ready for Mars whatsoever. We have been to the moon. We're going back to the moon with Artemis. And so the moon's environment is not pleasant whatsoever. Mars is even worse. So again, it goes back into we need to understand the landscape, the environment, make sure that we can report back to Earth and go like, hey, okay, you know what? Dust storms are a problem. Radiation is a problem. Volcanic glass and dust everywhere on Mars is a problem. What can we do with our technology to then help with that? What kind of spacesuit designs can we deal with that? What kind of habitat materials can we use to not bring in so much radiation? Can we build habitats underground and tunnel systems versus 3D printing is becoming a huge deal now. Can we 3D print with lunar and Martian materials, which would be really cool? And people are doing that, which is great. So it all again comes down to what can we do now to get us ready for then? But we're not ready to just hitch a ride on a rocket and just go.
Right. Right. And I remember, I think maybe it was with you, I'm not sure, but we had a talk a while back. And you said that the technology for us to get to Mars is already there, but the problem is preparing humans to live on hostile environments like the ones present in Mars.
Absolutely, absolutely. And Mars is not a forgiving planet. And it's such a weird planet too. But it's gorgeous. By all means, let's go explore it. But we need to be ready for it first. And so going back to the moon is the best first step.
Mhm.
You know, set up some sort of base at the moon. Let the moon be kind of like a nice home
Outpost.
base on the way. You
Mhm.
know, it's a good first step. But we have a long way to go.
Yeah, yeah. And there are many discussions and debates that are springing up about the full-scale colonization of Mars. So, do you think it's possible for us to terraform Mars right now, or do we lack the technology?
Oh, for sure. We definitely lack the technology of even terraforming. And it would be it's kind of like a utopian daydream at this point.
Right.
But technology, where do you even begin? It Mars does not have an active core, and therefore it does not have an active
Mhm.
magnetic field. Because it doesn't have an active magnetic field, you don't have a thick atmosphere. And because you don't have a thick atmosphere, here comes all the solar radiation and wipes out all of your
Right.
habitability there. And
Right.
so could there potentially be current habitability or even fossilized organisms there? Yes, just not at the surface. More than likely, it's got to be down in the soil.
Right.
But now between the harsh environment of Mars and then we also have to be aware of the NASA policies of planetary protection.
Mhm.
It's called the PPP. It's the Planetary Protection Program under NASA. Uh, it's been a fairly recent program over the past couple of years, but we're constantly adding policies to it. It's a consistently changing uh, document policy, if you will, where you know if we were going to go to Mars, we have to be very careful that we're not
Mhm.
going to just absolutely trash the place, and vice versa.
Yeah.
Bringing samples back to Mars, make sure we're going to be okay. And as much as that sounds like a B-rated sci-fi movie of like what could go wrong, um, we still need to be very careful on both ends here, Earth and Mars. And this goes for the moon. This goes for any moons and objects in the solar system.
Sure. So it seems like the problem is not strictly pertaining to science, but it also has legal implications, policy implications as well. So it's a really complicated web that we have to navigate before we arrive at some sort of a solution. And that document, it's the PPP, right? The PPP.
Yep.
Um,
Yep.
yeah. So that seems to be getting more and more complicated year by year, from what I'm getting at.
Yeah, yeah, but you know what? It keeps us on our toes because because then it helps us advance our technology
Yeah.
better. So, say if you wanted to sample the water at Enceladus,
Mhm.
how do you sample water without contaminating it? Because goodness gracious, you don't want to contaminate, ocean water on another moon. That would be bad, and that would go against the policy. So if anything, it's helping us rethink about our technology and rethink, okay, how can we better be with our technologies on other moons, but also how can we be better with our own technologies here on Earth as
Mhm.
well? Make sure that we're keeping our own waters clean and developing better technologies for our own planet, which is very fascinating. So, as busy and chaotic as it can be, it's helping us.
Yeah. So, given that the feasibility of colonizing or terraforming another planet is it's not possible right now. then many people have often questioned the entire enterprise of the space program. They always claim, why are we spending so much money up there when there are so many problems down here? And it's immediately obvious to those who have some sort of background in space science that looking up is just as important as looking down. For
100.
example,
Yes, I fully agree.
right, yeah. And for example, there are spin-off technologies in space exploration that have filtered into other fields such as health and medicine, computer science, image analysis, and other fields. But as a space scientist, as an astronomer, how do you specifically respond to this question when you're asked it?
Well, a couple of different ways. I definitely love your answer that advancing our technologies for space exploration, we turn it around and see if we can use our own technologies here on Earth. A great example of that is our water filtration system on the International Space Station. So converting, not to sound gross, but converting astronauts' urine and sweat into a drinkable water source.
Mhm.
And so having that entire technology, how can we process it? How can we almost like miniaturize it and make it more accessible and cheaper for all around the world? That would be absolutely fascinating, and it's still being worked on because that filtration system is still fairly new to us. And so that's one example. But another example too is that I think whenever people hear the word NASA, they immediately think space, which is cool by all means. Hooray! You know, we're very popular with space, but I think a lot of people forget that there's also a huge branch of NASA specifically for Earth.
Right.
The Earth branch of NASA also has a huge swath of different kinds of Earth observatories. There's weather
Mhm.
observatories. There's even an anthropology branch, which I just recently learned about not too long ago.
Right,
It's
yeah.
so cool. They actually have anthropology dig sites, but it's all under NASA. And so yes, NASA itself has a very tiny budget.
Right,
On
yes.
a congressional scale, NASA has an incredibly tiny budget. And for that budget, it doesn't all go into space. We have to divide it very carefully
Mhm.
between space sciences, and even with space sciences, you combine it off to solar system, planetary, and astrophysics. So all the gamma ray telescopes and the X-ray telescopes and black hole and galaxy studies go into that branch. And then you have the Earth sciences, and then you also have heliophysics as
Yeah.
well,
Uh-huh.
learning about our sun and solar dynamics and solar storms. So those three main branches, space, well, heliophysics is technically in space, and then the Earth sciences, all of that in one tiny budget of NASA. It's very difficult, incredibly difficult. But Earth sciences is incredible under NASA, and they actually just approved a new Earth monitoring satellite not too long ago too, back in early June, I believe.
Mhm.
So we're having new technology with Earth sciences. The unfortunate part is that it's not getting enough media attention. And
Yeah.
I think everyone's getting, because space is shiny, space makes news. Unfortunately, when it's like, oh, okay, another Earth observatory will be, but it's specifically to help look at hurricane systems, I believe, and
Yes.
also certain wind currents. That's going to help with a lot of the wildfires that's been cropping up. So I believe that's what that observatory is planning to do.
Right. And I think Neil deGrasse Tyson, of course, he's well renowned in the entire astrophysics community. He said that spin-off technologies are often misunderstood in the sense that many people just think that why should we have space exploration develop these technologies? Why wait for them? Just make them immediately. But often the insights are not there here on Earth. And so it's not immediately possible to apply these spin-off technology, apply and make new technologies here on Earth. In fact, there was a quote, I'm not sure if I can find it on the internet, but he did say something related to how microwaves were invented and how the military actually had a fundamental role to play in the development of some of these technologies. And it wasn't necessarily obvious immediately that we could use some of these microwave technologies in the real world. We had to have the military experiment with them, experiment with radar and some other telecommunications technologies in order for us to actually get these technologies into the real world, so-called. So, there's all sorts of different crossroads and streets that connect not only space science and what's done at NASA, but also the real world and real life.
Absolutely, yes. And it takes time. That's the
Yeah,
thing too. It's not as quick as, Wi-Fi. It's not quick whatsoever. And you're also dealing with a lot of large teams with a lot of these instruments too. So it takes time and a lot of communication, back and forth communication to even build even a prototype.
of course. And I think even Wi-Fi itself dates back and has some applications of space technology. So
Absolutely.
that itself is really amazing. And the public often misunderstands that we're just blowing up a bunch of money, loading it into a rocket and burning it up in space, but that's often not the case. And you also have to think, okay, well, how much money do you think we're actually spending on NASA? And you said it perfectly well. We're actually not spending like $1 trillion, not in the military's budget for sure. We're spending, I think it's $23 billion, which is, I think Neil deGrasse Tyson also said this, half a penny on a tax dollar. So it's not very much money. And with that, we get so much technology. So it's incredible.
It is. And it's amazing that even though we do have such a small budget, it is very exciting to see how resourceful we can be
Yeah.
on such a shoestring budget.
Of course, yeah, yeah, and certain segments of the budget, I think, are also spent on things like the light sail project, and that was, I think, spearheaded by the Planetary Society, if I'm not incorrect, or was it some
Yep.
other? Right.
No,
Okay.
it was the Planetary Society. Yep.
Right, sure. So apart from colonizing other planets, we also want to try and explore some new star systems using these innovative techniques. Do you think these technologies would work, and are they possible?
Absolutely. But again, takes time. But light sail technology, we've already launched prototypes, and they've been working out really well. We're trying to design it where it's like, can we make it bigger and better? Can we make the geometry of the sails different somehow? What kind of battery life and laser power could you have for something that's going to be way far away from any light source whatsoever? So again, all of this technology, it's absolutely possible. It's again not going to be available next week.
Right.
Uh,
Yeah.
thing, but it's going to be very exciting because there's already think tanks out there that are wanting to go to nearest neighbor stars. One particular think tank that comes to mind is something called Breakthrough Starshot. This was founded in 2016, and so having some sort of solar sail technology already pretty much available, but can we modify it for longer distances and eventually end up at Proxima Centauri? That would be neat. That would absolutely be neat. When's that going to be? Oh, it's going to be quite a while.
Right. And actually, the idea, I think, has been around for a while. I think when Carl Sagan first appeared on Johnny Carson, he talked about the idea of using a light sail to go to other star systems. And it was really fascinating for the public because they thought, we might be seeing new types of life forms like alien life and all. So, it really glued the public's interest. Now, I guess, talking a little bit about alien life, in 1961, Dr. Frank Drake created what's now known as the Drake equation, of course. And that was used to estimate the number of technologically advanced spacefaring civilizations that might be there in the Milky Way. Now, as an extension to this, I think there was a recent study that was performed by a university in the UK that claimed that there could be numerous advanced civilizations with powers to communicate with us via radio. So is contact with alien life in our future?
Absolutely. I fully believe that. However, I don't think our technology is as great as we think
Right.
it is. So even if there's all of these wonderful civilizations out there that are absolutely communicating with each other, even just trying to communicate with us, we may not even exist to them yet. But just sending signals out. The problem, though, is that they could be using an iPhone 11, and we're still in the rotary phone age,
Mhm.
um, uh, considering technology here. So just because we think our technology right now is so outstanding, it may not be enough. There could be all sorts of signals coming to us. We just don't know how to listen yet,
Mhm.
and vice versa. That could very easily be the case for other civilizations where we're the powerful ones sending out all these signals, and Bob, 3 galaxies away, can't pick up the phone. It's still a fascinating all the different kinds of theories out there, and it's wonderful. It's absolutely chaotic, to be sure, because there's so many different kinds of theories. But who's building the better phone, and
Mhm.
who's building the better receiver to pick up the phone and go, "Hello, we're here." That it all comes down to that. But could there be other civilizations out there? Yeah, I believe that. Absolutely. That's a lot of space out there.
Yeah, and I think this is one of the most intriguing topics in space science for at least the layman. They think, okay, oh my gosh, we're not the only civilizations in the universe, and that's a humbling fact. And in fact, there's a lot of scientists and engineers that say that there might even be life in our own solar system. Like they detected phosphine in the atmosphere of Venus, and that led many experts to speculate on the existence of life in the clouds there. Mars, as I'm sure you know, is also a candidate for life, and even moons around planets such as Jupiter, Europa being most notable, might host life under its icy crust. Now, do you think there might be life in our solar system? And if so, what do you think is the probability of that?
I that's still a really interesting debate, and I love listening to debates because I've heard both sides. I've heard like, yes, absolutely, like little tiny microorganisms, you got to be out there. But I've also heard the pros and cons too, and I've heard the cons where it's just like, no, maybe it's almost too extreme of an environment, or what if we accidentally contaminated the oceans? Could we accidentally introduce
Mhm.
our own earthly
Right.
organisms to that environment? What could possibly happen? And so again, very fascinating to hear both sides of it. My personal view is that, yeah, microorganisms can live in very extreme
Mhm.
environments, even here on Earth. We've actually seen organisms thrive at radioactive areas in Chernobyl still, and they thrive within a lot of like nuclear plant
Mhm. Right.
towers. You also have microorganisms that live in like the saltiest lakes on Earth. You have volcanic systems, and you have hydrothermal vents. Well, guess what? There's volcanic systems and hydrothermal vents all over the solar system, and including Europa and Enceladus for hydrothermal venting. That would be absolutely perfect because I think a lot of people think, oh, you need sunlight. You absolutely don't. All you really need is some sort of basic hydrogen, molecular hydrogen, and just some sort of energy source.
Right.
Hydrothermal vents are perfect for that. There is a lot of molecular hydrogen within oceans because you got H2O, but you also have the energy, all that tidal force pulling the moon and constant venting of material. There's your energy source.
Mhm.
So, could there be microbes in the oceans of Enceladus and Europa? Yeah. Now, could they be in the clouds of Venus? That's still under debate right now because that phosphine detection is still a yes and no debate.
Mhm.
And so it's going to be very exciting with the 3 new Venus missions that were just approved of just a couple months back. So we have Envision from the European Space Agency, and then we have Da Vinci and Veritas from NASA that are going to go to Venus. Now, their prime objectives are nothing to do with phosphine, but the signals that they can get, all the detection, all the chemical signatures that they can get off of Venus may prove or disprove the phosphine detection. So that's very exciting as well.
Right. And so, assuming, let's say, we do make contact with some sort of extraterrestrial civilization in another star system, do you think it would be wise for us to advertise our existence? Because many scientists, like Stephen Hawking and Michio Kaku, say, well, it's going to be the same sort of situation when the Aztecs arrived here in North America. And that didn't turn out, excuse me, not the Aztecs, but the Europeans arrived here in North America, and it didn't go too well for the natives that lived here. So maybe we could be the natives in this situation, and the extraterrestrial civilizations with technology hundreds of thousands of years more advanced than us, could pillage and plunder our planet.
So one would hope, and I believe Neil deGrasse Tyson, or at least Bill Nye, have made discussions about this before, but one would hope that if they were to answer back, that means that they have intelligent technology enough to answer back and say hello. But one would hope that these are also of scientific minds as well, that they would want to study us. They would want to study our planet, our habitat, our whole solar system. So one would hope that they have more of like a scientific endeavor and not a like a Marvel comic universe, let's just devour the
Right,
planet kind of
right,
deal.
yeah.
Let's hope that they're scientists and that even they may have like their own planetary protection program. Make sure
Mhm.
that they're being safe and we're being safe. And hey, we want to come visit, but how can we set up a meeting?
Right. Let's set up a Zoom meeting and
Yeah, exactly. Intergalactic Zoom. Now there's an idea. Oh dear.
right. Yeah. Yeah. Well, that sounds incredibly fascinating. And I personally hope that we do meet some sort of extraterrestrial intelligence within our lifetime. Having said that, what advice would you send to students that are interested in pursuing a career in STEM, and specifically astronomy and physics? And as a scientist, a communicator, and an educator, what sort of curriculum do you think we should enact in schools across the country to bring about a transformative change in the manner we instruct students in STEM?
Fantastic questions. So your answer to your first question, I honestly, my advice is just to follow your curiosity. You shouldn't have to just wait to sit in a classroom and learn. Go to the library. Google is now in the palm of our hands. I go get textbooks. Again, you shouldn't have to wait and allow yourself to sit in a college classroom or even a high school classroom and wait to get the textbook then. Go out and get a textbook now and read and learn and follow your curiosity. If you have a burning question, email scientists. We love answering questions, and I hope to get someone like me that I could just talk and talk and talk. uh, but we love talking and communicating about our sciences. That if you have a burning question, it's perfectly okay to email people and again, follow that curiosity. Maybe you have a question and you're like, I wonder if this has been done.
Mhm.
Maybe it has, maybe it hasn't, but you won't know until you take that first step and really go for your curiosity. So that would be my advice for anybody out there who wants to pursue STEM. Answering your second question, then, what can we do to better our curricula? There's quite a few things that can be improved. One major thing is that we love communication, but what I'm realizing now, especially with undergraduates and graduate students nowadays, is that there's not enough writing. We have, as our careers,
Mhm.
I pretty much depend upon funding. Well, funding includes writing proposals. And guess what? writing proposals, writing technical reports, writing conference abstracts and journal articles. It's an art form and it's a practice and it's hard. It is incredibly difficult.
Mhm.
And it goes easier the more times that you do it. But if we had a better foundational writing program specific for STEM majors all across universities, I think that would really improve how people can get proposals funded and journal articles submitted. It would make their careers go a lot smoother instead of having to figure it out while you're trying to get your PhD.
Right.
It's absolutely maddening. I was lucky enough to go take a creative writing class because that was the only writing class I was offered during my time at college. Whether there's technical writing classes out there nowadays, that would be great, but it needs to be more widespread. It shouldn't have to be at very specific colleges. It needs to be offered everywhere. So that in itself should be very much an improved thing with the curricula. Other things I think more departments are having a better idea with too is just having like journal clubs and seminars
Right. Yeah.
where you bring in whether you bring in guest speakers and it helps the students kind of network a little bit. I've seen some journal clubs go through ethics of science, which is very exciting too. There's a lot of different ethics that need to be brought to people's attention. And better to learn it now than experience it in a potentially bad way in the
Right.
future.
Right.
So understanding ethics, understanding policies, understanding etiquette, like conference etiquette, how do you email someone that you've never met but you want to network with them? What's the steps of networking? So it's kind of like training you to be a scientist. And I think that those kind of skills can definitely be in a journal club or a seminar type setting, which would be exciting.
Yeah, for sure. And actually, one suggestion I had was you interest students very early on. So you interest them with subjects like astronomy, paleontology, artificial intelligence, earth science, et cetera, et cetera. They don't necessarily have to learn the subjects then. What happens is they start to develop an interest for STEM. And later on, when they have matured, they have some sense and directionality. They have passion to pursue and not fear subjects like math, which is the language of the universe. So then they ultimately take upon challenges, they pursue majors in STEM fields, and they ultimately make society better as a whole.
100% agree. Absolutely. I think what stemming from that idea, and it's a fantastic idea, I think what's happening then is that we need to have better resources for teachers because now we're finding that most teachers may not even have the resources to teach it, or they're scared
Mhm.
to teach something that they themselves have no earthly idea or even
Right.
universal idea in this case about. And so, if we had better resources for educators to be able to make them comfortable talking about these subjects and maybe give them better connections to scientists as well, that would open up networking for the teachers. It would help with networking with their students. Resources are always free through NASA, but the whole teacher education globe is so extensive that if we could just have more and more resources and that the teachers become more and more aware of these resources,
Mhm.
that's the kind of the disconnect going on right now. That part needs to be more aware, absolutely. Because then once the teachers are comfortable, then you can start to get the students, the kids way more excited early, 100%.
Course. Yeah, and definitely we need educators, we need scientists, we need communicators like you so that we can interest students even more and potentially have them go into some of these so-called hard STEM fields. But anyways, Dr. Ahrens, it was a pleasure speaking with you today. It was short yet informative podcast. And I'm sure our viewers had as much fun listening as I had conversing with you. So once again, thank you so much for being a part of this. And I look forward to talking to you again soon.
Thank you so much for inviting me here this evening. I had a blast. I hope I can be invited again. I'm so excited to listen in to more episodes that you have to offer in the future.
Thank you so much, Dr. Ahrens, and take care.
Thank you. You too.